Okay, good evening to those people who are joining us just now. It's the latest GSHPA webinar. We'll just wait a minute for a few people to join. There's 32 registered to attend the event this evening. We'll just give it a second or two. See how many more come in. If I could just ask you to make sure that you are muted and your videos are off, I would really appreciate that. Okay, I think we'll make a start. It's 7 o'clock. We don't want to be late. So good evening, everybody. I'm Andrea Ellison, and I'm the Chair of Marketing and the Treasurer and the Director of the Ground Source Heat Pump Association. And I'll be hosting this evening's event. Just to let everybody know that we are being recorded and a live video will be on YouTube and a catch-up will be available on YouTube as well. But this is a recorded and live event. It's a local heat pump awareness event, and this evening we're focusing on some of our members who are in Yorkshire, Derbyshire, Nottinghamshire and Lincolnshire, but we're hoping to have a bigger sort of national audience as well, and everybody's welcome to attend. I have our association administrator Stephen in the background working the Zoom, making it all happen, so we want to say thank you to him.
Good evening.
If you have any questions, could I ask you to use the Q&A at the bottom of the screen rather than the chat? If you go to the bottom of the screen, you'll see Q&A, and if you can save your questions until the end, and then we will come back and we will work with you on those questions that you might have. Don't be shy asking questions. Very often people think that they might be trivial and silly, but really they're not, and because most other people will be asking the same question in their head and a little bit afraid to ask. So please do shout up and ask your question, no matter how trivial you think it might be, because it does matter. So I'm going to introduce you now to this evening's presenters. Emma Bohan is the General Manager of IMS Heat Pumps Limited, based in Sheffield. And we've got her colleagues Andrew Hubble and Lee Brown, who are also from there, they're heating contractors. And we've got Jake Ball from Ground Source Drilling and Contracting, or GDC as we like to call them, who are based in Kirkby in Ashfield in Nottinghamshire, and they're experts in the drilling of boreholes and the ground heat extraction, so that's their part of it. So Emma and her team are as I say, the internals, and GDC are the externals. That's how I like to put it. So as I said, please use the Q&A session questions button at the bottom, and I will now hand you over to Emma, who will start this evening's presentation. Thank you.
Hi, everyone. I'll just share my screen, get this kicked off. Okay, so a little bit of introduction about us. IMS Heat Pumps, we were established in 1997. I think we've been putting heat pumps in since around about the year 2000. MCS accredited, Trustmark approved, offices in Sheffield and Perth, and we specialise in the design, supply, install, maintain and service of air source, ground source and water source heat pumps and the heating distribution systems that they work with. And I'm joined tonight by Jake Ball.
Good evening, everyone. As Andrew has quite nicely summarised, my name's Jake, and I'm here on behalf of Ground Source Drilling and Contracting Limited, aka GDC. We've been trading since around 2008. We provide a full nationwide service for all of the external works relating to the ground source heat pump, such as vertical boreholes, horizontal trenching systems and lake loop systems. This includes drilling and grouting of boreholes, trenching, geo-loop installation, the header pipe connections and the earthworks, which, as Andrea summarises, mainly the external works, which we'll talk about a little bit more in depth later on, and hopefully answer any of your questions at the end.
And just to recap, ask any questions at any time. My screen here is missing the actual bubbles, but between participants and chat, there's the little Q&A function. And any time throughout the presentation, if you type it in there, and then Andrew will pick them up at the end. So I thought I would start with, why heat pumps have suddenly kind of appeared in the mainstream. Really, there's a bit of a fuss, these new heat pumps and how they're going to help us with our net zero targets, climate emergency, carbon emissions, things as to where heat pumps are. But really, they're not new. The first heat pump built in the way that we know it now was about 1856, and the heat pump is a principal form of heating across many European countries already. I personally am aware of heat pumps being installed in this country mid to late 90s, and they've been on the government's agenda since 2000s, mid 2000s. But as the awareness of climate change and the fossil fuel issue has risen to the fore, the government has done more and more about it. And, they've really, Green Homes Grant announcement and the 10-point plan have really launched them into the fore. And so we've seen the increase in government policy and agendas and audits. And now we're looking at, future legislation where heat pumps become the norm and the gas boiler goes. And kind of why are they looking at this? Well, the average household emits 2.7 tons of carbon every year. There's about 25 million homes heated by natural gas, and about 48% of those people are not aware that they are actually a source of carbon emissions. In addition, we've got about 3.7 million homes using non-main gas fuels, oil, LPG. And within the home, a vast proportion of our energy costs are on our heating and hot water. And in the domestic setting, we're contributing about 17% of all carbon emissions from domestic homes. And the cost of heating our home is rising. We are actually using less energy with smart meters and energy saving devices, but the cost still increases. And heat pumps provide a solution to this. This is a slide that drag out quite a bit. It's actually from 2012, and when it was DEC and not BASE that we were looking at to lead the charge on this kind of information. And even then, they were looking at heat pumps as being, one of the main providers of heating by 2050. So, how does a heat pump work? Well, it's effectively a fridge in reverse. So you plug it into the electricity, and that then powers the pumps that draw heat from the ground, or in the case of air source, from the air, into an evaporator, which causes the refrigerant to cool and evaporate into gas. And then you compress the gas. And if you think about using a bicycle pump, if you were to put your finger on the top of it while you were pumping, you'll feel it get hot. And that causes the temperature to rise, and that's what's used then to heat the water that goes through the domestic radiator underfloor heating system and provides the hot water for your showers and your baths and your sinks. However, not like a gas boiler or an oil boiler, this is at a much lower flow temperature. So heat pumps can provide constant heat and a nice ambient temperature with flow temperatures of around 35 degrees. And the low carbon view of heating is that it should at least be 55 degrees or less. The system uses about 1 kilowatt of electricity in order to power the compressors and the circulation pumps, but this will provide 3 to 4 kilowatts of heat into your home, sometimes 5 kilowatts of heat into your home, which is what makes it an efficient use of electricity, as well as the fact that electricity, we are producing more electricity through renewable means, a much more lower carbon source of heating in the home. And this efficiencies in heat pumps are known as SCOPs, coefficients of performance, and every heat pump comes with a nameplate SCOP, tested in lab conditions, at set outdoor temperatures, set flow temperatures. You'll see them on the side of the boxes. So, for instance, we use the Valent Flexotherm. It's got an on-the-box 4.73. The NEBI S1155 12 has got an on-the-box SCOP of 4.99. Air source heat pumps tend to have slightly lower SCOPs, but even they are getting better all the time. And when it's running, the heat pump will fluctuate over the year. So you'll tend to get a better SCOP during the warmer months a lower scope during the colder months. It fluctuates slightly wider over the air source because the temperatures are different in the air as opposed to in the ground. But this is what then creates a difference in the running cost of a heat pump. So this graph, I've used fuel cost data from the Energy Saving Trust. I mean, I know I pay a lot less for my gas and a lot less for my electricity, but some verifiable data from the website there. But based on the efficiencies of the system, you can see then that there are cost savings to be had on actually running your home, as well as the on lower carbon, less fossil fuel. Just touching then on a kind of different heat pumps. So you've got the air source heat pump, an excellent solution for properties where ground is limited. You're having the fan unit outside, which is extracting the heat out of the air. So you don't have the requirement for groundworks, you just have the unit sat outside. Like all the heat pumps, it's going to need more interior space than your average combi boiler that we're used to. You've got a control unit, you've got a hot water cylinder, you've got the ancillary buffers and expansion vessels that go with that system. Air source, just touched on it, not as efficient in winter as a ground source, because underneath the ground you have a steady 8 to 10 degrees, but the air is more fluctuating. Relatively straightforward to install in most cases, and permitted development rules, so not a lot of planning. There are some considerations, but generally suitable for most homes. Just a few pictures here. We've got the down at the bottom, if I try and get my pointer to work. So this is, we use a NEBA and a Valent system. So these are the catalogue views of the heat pumps, and here are some in actual action. So Valent outdoor unit, this is a cascaded or a two-system NEBA, and the kind of view of the plant area required. So domestic hot water cylinder, buffer tanks, expansion vessels, control units. Water source heat pump, not many of us with the potential for this, but if you do have water on your property, then they are an excellent solution. Similar in cost and efficiency to a ground source heat pump, although instead of using the vertical collectors and trenches we'll look at in a minute, you've got weighted pipes in your water, or energy blades, or pumps, which are placed in, you know, your lake, if you happen to have one, or your river, or indeed wells. It can be complicated to specify. We do have to do a lot of work on flow rates and temperatures, and of course, you know, the installation in a water scenario is slightly interesting, and you may require some permission from the Environment Agency. Some pictures here. We recently did an energy blades install, a converted mill. This was pre-boxed in. This was the kit that powers it all. This is what it looks like when they built a nice little home for it. This is either Andrew or Lee. It's a lake just outside Sheffield, which you know, we did, and that works very well. Ground source heat pump. So here we are with the Ground Source Heat Pump Association. So these are ideal for large properties. You do need the land, or you do need the access for the drilling rigs. New build properties, obviously that's a kind of no-brainer. You've already got the availability to have boreholes done, maybe when you're doing your foundations, but absolutely we do these in renovations and retrofits too. They are more expensive to install because you have the groundworks associated with them, but they do give you, you know, the better efficiencies and the lower temperatures because of the constant temperature in the ground. You don't have the external fan unit, so you've got none of the. I know that there's talk of noise associated with air source heat pumps. They are pretty quiet, but you've got none of this with the ground source, and again, no need for planning permission in most cases. Couple of pictures here. So we've got an aerial view of trenching, where we've kind of plotted out where you've got your pipe work going to and from the ground source manifold. Couple of views of the boreholes when they're finished, but it's the same kind of setup. These pipes are going into a manifold, which is then going into your property. One of GDC's rigs on the site here, and ground source. So you don't have a fan unit, but you have got a slightly larger indoor unit. But again, it's the same thing. You've got buffer tanks, you've got expansion vessels, you've got the units required to run it. Heat pumps. So you want one, where do you start? I think we'll just do a couple of myth-busting situations here. So first one, a heat pump can't be installed in an existing property. I can tell you that about 45% of our business is in existing properties, renovations, retrofits. They absolutely can be installed. Obviously, new builds, as I've said, no-brainers. You plan it in from the start. We work with the architects, decide where your stuff's going to go. Your trenches are dug out at the same time your foundations, or your drillers are on site when the access is good. But in a renovation or retrofit situation, it's just about understanding what we can do and what we can't, and whether that's going to fit with you, and how it's going to fit in with your property. You know, we do a lot of oil boiler replacements, what we would call a retrofit. Again, rural areas, they've got the land, the access is not a problem, and then it's just about, you know, how do we go about changing out that oil boiler? A heat pump can't be installed unless the property has lots of insulation. So it doesn't matter what your heat source is. Sorry, excuse me. Effectively, you can heat any old drafty property. It's just going to work harder. It's going to work longer. It's going to need a bigger system. It's going to cost you more. So we do like to think about a fabric first approach, whereby if you can do insulation in your property, if you can put some double glazing in, then you're going to need a smaller unit, and you're not going to spend half your money heating the outside world. But that's not to say that it can't be done. And we do it. We've done grade 2 listed, where there's issues you can't insulate certain parts. The RHI, which is one of the funding streams available, or currently the only funding stream in England anyway, has minimum insulation levels. So I think this is kind of where this has come from. If you want to apply for RHI, you do need loft insulation if you can have it. You do need cavity wall insulation if you can have it. But if your property can't have it, we can still look at the technical solution to how we can heat your home. It doesn't work when it's cold. It does work when it's cold. In terms of, you know, the scops, the fluctuations, then, you know, your scops might drop slightly in the winter. But we've just experienced one of the coldest snaps in Scotland for 10 years, and our director's heat pump was running a minus 9.4 outdoor temperature and a cozy 21 degrees internally. They absolutely can. They are used a lot in the Nordic countries, where, you know, we experience much colder weather than it is here. So they absolutely can perform in cold weather. And a heat pump needs a backup boiler. Technically, there are some reasons why a hybrid or a bivalent or a dual fuel heat pump would be specified. We are a bit heat pump purists, and if you can do a heat pump on its own, which we find that you can in most cases, then why not do a heat pump on its own? Clearly, if the output on a single phase unit is not going to meet the output required by a small amount, then yes, you can back that up with a boiler. But in most cases, you find that it doesn't need it. It just needs to be economically viable also. So then you start thinking, well, which heat pump's right for me? You know, the first question you ask, have you got any land, or have you got access for the drilling rigs? You know, if you haven't, then you're going to go air source. But if you have, there's no reason to rule out ground source. You don't have a fan unit. The air source heat pump doesn't have the groundworks required, but it does need somewhere to site the outdoor unit. You're going to need a slightly bigger internal space for the plant on a ground source than you do for an air source, but you're going to get the better efficiencies out of a ground source. Air source, as I say, they are catching up, but you're still going to get those better efficiencies at the present time. Bigger outputs from a single unit solution on a ground source than you will for an air source. But then it comes down to, you know, the capital cost. It's going to cost you more. You've got groundworks associated with a ground source heat pump that you don't have with an air source heat pump. But this is then where the RHI kicks in, because you will get more funding for more energy out of the RHI for a ground source than you would for an air source. So where do we then start once you've kind of looked at, you know, what your property may or may not be suitable from? Well, we're coming to you with an accurate energy assessment. We're doing a heat loss calculation, a room by room heat loss calculation. How thermally efficient is your property? So going back to the fabric first insulation approach, you know, if you've got a really thermally efficient property, you're going to need a smaller unit that can run at a lower flow temperature, and all of those things help you both on running costs and capital costs. But this is where we are looking at, you know, Do you have double glazing? What's the U values of your roof? How many, holes in your walls have you got? It was just, these are the kind of things that all inform what heat is needed to keep that room at a nice cozy temperature, and then adding all your rooms up to say this property needs this size unit to maintain that ambient temperature. Over to Jake, we'll talk about collectors.
Thank you, Emma. Just want to explain a little bit more about the vertical collectors, or the geoloops. As we've mentioned already, they're installed into boreholes that are drilled down into the rock. So effectively, the first step is that it's designed by a heat pump provider, such as IMS, who will consider a lot of the things mentioned, namely the output that's going to be required for the building, the type of insulation that it's got, the budget of the client, and the space that the property's got as well, and the geology. So each different rock type's got a different conductivity. For all these factors together, we can determine how many holes that we'll need and how deep they need to be. As an example, typically a small domestic property will need between 1 and 3 boreholes, ranging from probably 80 to 150 meters below ground level, and we ensure that they're a minimum of 6 meters away from a property, but each borehole, if there's more than one, has to be a minimum of 8 meters apart from each other. So the process, if this is the right system for you, is that we'd have to mobilize and set up a drilling rig on site, and this comes with a lot of ancillary equipment as well, such as a water tank, a telehandler, or forklift. Boreholes are then drilled to depth, and what we like to pride ourselves on, drilling at as small a diameter as possible, namely 120 mils, which is 4 3/4 inch. The smaller the hole, the better conductivity you get from the rock. Once we've drilled the borehole, we'll install the geoloop, or the collector, as it's been called as well, and a grout pipe to the correct depth. They're pressure tested to make sure that they're all still intact and nothing's been damaged in the process, and then that's grouted up with a highly thermal conductivity grout from the bottom, so that the hole's full from top to bottom, and you can get the maximum return from that. From there, you effectively just move on if there's a second hole, and do the same process again, and repeat that until all the boreholes have been completed. And then we move on to what we'd call the header connection works. That section is effectively joining those boreholes to the property. So you'd be connecting the pipes that's been put into the boreholes via trenchers into a manifold chamber, and from the manifold chamber there'd be a flow and return pipe, which would enter the building, usually at the plant room, or whatever space has been allocated for the heat pumps. Then we'd backfill, pressure test all of that system, sanitize it as well to make sure that there's nothing that can affect the system before it gets its glycol put in it. And then if it's usually handed over to the heat pump provider again, who will take care of all the internal works. Moving on to the horizontal system. Oh, sorry, we've got some pictures first. Up in the top left there, that's a picture of the drilling rig on a property that we did a few years ago. Just below that, you can see a bird's eye view of a completed borehole. So you can see somebody's boot in the top right hand corner to give you an idea of the size of the hole that's left. typically at surface it might be up to 6 inch where some casing has been installed, but it's all gratted up so that effectively once the work's done, it's buried below ground and you don't even know it's there. And picture on the right as well of the rig. On the other hand, there's a horizontal or trenches collector system. If you've got space for this, the same principle applies where heat is taken from the ground. However, instead of mobilizing the drilling rig and drilling down into the rock, it's a series of long trenches that run across the land. These are typically 1.2 meters deep, and there are various types of collectors too, which I think may be on some of the pictures that follow. Some are called slinkies, which are a bit like a coiled system which is stretched into the trenches, but more commonly it's a straight pipe, a bit like the pictures in the bottom left, where you run it down a trench and back down the other side, a minimum of meter apart again, back to a manifold system and back into the property, just as with a vertical system. Some pictures there just showing the process of works again. The middle picture you can see it's already been nearly backfilled. There's a marker tape's laid in the trenches. It's usually a green marker tape, geothermal warning marker tape, so if there's any future digs that they're aware there's pipes there. The bottom left shows another example of a manifold chamber with all the horizontal pipe work coming into it before it goes off to the building.
Thanks, Jake. Yeah, and just this bottom picture is a picture of land after trenching and when it's just been left back to its normal arable beauty. So yeah, once they're in, and you carry on. So that's when we look at space, place and layout. Whereabouts in your property are we putting all of this planting equipment? A couple of different layouts for plant room there, you know. Most of these things are around a 600 by 600 footprint, which most people are used to in terms of your kitchen layout, kitchen cupboards, domestics, but it's the where that's going to live, and we can split this. You know, it doesn't all have to live together. We've got split systems where your cylinder might be somewhere else and your controller somewhere else. We've got them where they're in garages next to the house and you just pipe the flow back in. We've had clients who've built purpose-built huts outside for them. So there's lots of different ways to organise a plant room. But if we're looking at new builds or even, you know, some of the renovation projects, you know, there's other things to think about. You have an underfloor heating where your manifold's going to sit, those connections, air source heat pump, where's the outdoor unit going to sit in relation to all this kit, and how you're going to get your pipe from one place to another. Again, new builds, easy to do. We're working off plan. We've backed it into the beginning. Renovations, barn conversions, where you're already doing a lot of works on site. Again, you might even have architects involved. We can get involved right at that early stage. Retrofits, it's about looking at what you've got. Clearly, some homes already have a hot water cylinder. That's good. Where a hot water cylinder doesn't exist, it's about where is the best place for that? What space can we steal? Because we are going to be putting a hot water cylinder in, you know, in the combi boiler world, we've spent a lot of time ripping out those red lagged cylinders that I know my mum used to switch on a Friday, coming back on a Sunday. We've stolen that space back and made it useful cupboards or expanded our bathrooms, but we are going to put one back in. There's some new technologies, Sunamp's a technology that reduces the need for a hot water cylinder, but it's still a piece of kit and it's still got to go somewhere. We're then looking at, you know, how big is that cylinder? Because how much hot water do you need? And this is about, you know, where we're really getting into. So we've bespoke designed the size of unit because of your home's thermal properties. We're now going to bespoke design how much water. And there's some minimum requirements. It's 45 litres a person. You still work with a chap who's praised with his people are not as dirty as they think. And 45 litres of hot water is enough for any person. But a lot of people, it's a bit like bread at Christmas, shops are going to be shut for 24 hours, so we're going to stock up. There's a fear that we'll run out. But it's also about, you know, how do you use your property? How many people are living there? You know, do you have dogs or horses that you use? You wash your car at the weekend. We do a lot of holiday homes, and holiday homes tend to have a completely different hot water usage than a standard family home. People come back from the beaches and, you know, having a shower in the morning, a shower in the afternoon. So really understanding your hot water and designing in that hot water priority, because you want the hot water to be always there. And unlike those red lag cylinders where your hot water ran out and you have to wait another 2 days for it to fill up, if you were unlucky enough to have a system where you could drain all the hot water out of it, these cylinders are going to be full again within 30 to 45 minutes. They work from the bottom up. As soon as you start drawing out of the top, they're reheating it from the bottom. So really understanding your home, how many people live there, what you want from your hot water. We design in the requirement, and the heat pump can provide that. And again, the heating distribution system, you know, this is where the heat pump is going to provide you with your cozy home. I often say, you know, in some respects, you don't really care what's providing the heat. You could have hamsters running in series. Unless your home is warm, it's not doing its job. And making sure that that distribution system is going to give you the heat at this lower design temperature. You know, fossil fuel gas boilers, if somebody's given it some thought, it might be running around the 55-degree mark, but more likely than not, it's running somewhere between 60 and 70. If you're in a retrofit situation, that's looking at whether that output for the radiator you've got in that room is going to still work at 45 degrees, at 50 degrees. You know, do we need to have a higher output radiator there? The myth that they're special radiators, they're not special radiators, this just might be a bigger output. So where you've got a single finned radiator, you might need a double finned radiator. Obviously newer builds and renovation situations, you know, making sure that that underfloor heating system is designed to work with a heat pump, you know, the narrower pipe spacing, all of these things are what goes into making sure that that heat pump really delivers that continuous cozy temperature for which it's synonymous with. Then the control system. There's an argument to say less is more. You know, the heat pumps have sophisticated control systems, the weather compensation systems. This is what they're designed to do. You know, it's cold outside, I'll be warm inside. But we don't. People have controls. You know, you're going to have that wood burner on. You want to turn that heat pump down, or the heat in that room down. You've got guest bedrooms that you're not going to use. Holiday homes where people aren't going to be. Clearly factoring in the control system. But how much control do you want? Are you a Hive or an Alexa user? Are you wanting to integrate this with some of the smarter technologies and MVHR systems, solar PV? All of these things are what are considered when we are designing the temperature, designing the distribution system, and designing the control system for your home. So once we've designed it, we're going to pay for it. And unfortunately, now the Green Homes Grant's gone, that means that it's a capital cost situation. But this is where the RHI comes in. It's not going to help you find that upfront capital cost, but it's going to pay you back over 7 years. It's domestic RHI for single dwellings. So commercial RHI is gone, and there's currently nothing to fill that void. It has got the minimum insulation standards that we talked about. And it's based on a calculation that uses a deemed energy requirement from your EPC, along with the renewable heat you're generating from your heat pump and the flow temperature. So the lower temperature you can get that design down to, the more RHI you're going to get. It's capped at 20,000 kilowatt hours for air source, more kilowatt hours for ground source, which is where the ground source can really win out in terms of, you know, favourable RHI payments. It's a post-installation grant, so you pay for it and then you claim it back, or you apply to have an application accepted. The maximum you're going to get for an air source is about 11.2, maximum for ground source, as you can see, 35.7, and it goes up with inflation. And once you're on the programme, it's going to pay you whatever that sum is in instalments quarterly over 7 years. If you've got a second home, if you've got a holiday let, if you've got a buy to let, You might need some additional metering, at which point it's a kind of reverse of your gas bill. So rather than you give them a meter reading and then they bill you, you give them a meter reading and they pay you. It's administered by Ofgem, and unfortunately it's ending in March 2022. This is some super funding, and it's the only funding available at the moment in England. So when we are looking at projects with clients, this is the kind of information that we're putting together. So not only are we doing the analysis of your design to get you the temperature to lower, to get you the heat pump design, to get your ground collectors designed so that somebody like GDC can come and install them for you. We are looking at, you know, what are your running costs and what does that look like as a comparison with a fossil fuel boiler. So this is the situation. If we just go back, sorry, this was a barn conversion in Sheffield. They were off gas grid, so their only alternative would have been to put an oil boiler in. So that is the comparison that we did here. You'll see that it was a capital investment in the first year of £23,500. That doesn't include the emitter side. The emitter side you've got to do anyway, whichever system you have. But you could have got an oil boiler for around £7,000. This shows you the RHI income and the fuel cost. So there was fuel cost savings from day one of what they would have been paying if they'd have gone oil. You throw in the RHI income, and this, I think, shows it all in that, you know, by year 3, it's paid for itself and you're just saving money. This kind of puts a similar project, but in a different way. So again, this was a barn conversion. It was actually a steading conversion that we did in Scotland. Oil boiler, this would have cost them £8,500. To run that would have cost them £2,600 every year. So 7 year, because we look over at the RHI, £26,700 for that system. Yes, it cost them £14,500 more to put the ground source heat pump, but we look at it as an investment, because immediately they were saving on their running costs, and then they factored in the RHI income. So that system over 7 years was 6,900. Over that 7 years, they got their £14,500 back and returned additional tax-free savings. You know, that system cost them £19,000, or saved them £19,800. Ground source heat pumps with RHI right now, there has never been a better time to get involved. And so, you know, just to recap on some of the advantages, it's low carbon heating. We're not burning the fossil fuels. Hook that up to a renewable energy electricity tariff, you know, your carbon footprint reduces and reduces again. Low maintenance. The warranty requirements and the RHI requirements are generally, you know, an annual service once a year. We've got heat pumps that were pre-RHI. The advice was, you know, shut the door, let it run. They're still running. Lower running costs against oil, LPG, direct electric, and in a lot of cases, mains gas. It really, you know, it's project by project, but we do definitely see running cost savings against fuel gas, especially with ground source heat pumps. And on a new build or a self build, it's one less new connection to pay for. No fuel deliveries, no storage of fuel, and long lives. Heat pumps, 10, 15, 20 years, cylinders of 20, 25-year guarantees. Collectors, we're talking 100 years. Once those collectors are in, they're not going anywhere. The only time I've ever seen a collector fail is the, you know, user error, chopping them up accidentally in the fields. The renewable heat incentive, you know, you're not going to get paid for putting a fossil fuel boiler in by anybody. And at the moment, you know, 0% on new builds, 5% on retrofits and renovation, subject to the new VAT rules on Labour v materials. But, you know, again, a saving there against a fossil fuel system. So where are we? You know, the world is saying that energy efficiency and climate change and low carbonisation is not optional. I tend to agree. And the heat pumps are right now the most excellent way of reducing your home's domestic heating carbon footprint. And with a balanced design, taking into account your home, your hot water requirements, how you want your heating distribution system controlled, whether you want underfloor or radiators or a mixture of both, can provide you with that cozy home, provide continuous ambient heat. low carbon, low cost renewable heating can be a really good investment. This is us. These are ground source, GDC, IMS heat pumps. And I think now we'll open for questions.
Okay, if you can stop sharing the screen, Emma, that would be great. Thank you for that. That was really comprehensive, very, very interesting. I've learnt something today. I go out and about for the Ground Source Heat Pump Association, and I love the end of the bicycle pump scenario. Using that, thank you. So I've got a little bit more for my banter and my patter today. We have got a few questions. I've got Ben and Anthony particularly asking questions, and I think what I'm going to do is just give Emma a minute to catch her breath. I've got two questions that really are going to be for the drilling team. I've got one question of, I have trees in my garden. Is it possible to map tree roots and avoid them? And then how much access does the drilling rig need? Now, my answer to that usually is if I can get a long wheelbase Land Rover in there, I can get the drilling rig in. But we'll see if you would agree with that. But is it possible to map tree roots and avoid them as well as the drilling rig?
Thank you. Yeah. Good question. So regarding the tree roots, what we'd probably do is get the local authority involved in anything like that. So the tree protection officer, just to take their advice on the size and the space required around the trees. Typically, if we're talking about drilling boreholes, if you're outside the canopy of the tree above ground, you're usually okay to proceed with the drilling underground. The trenching works are a little bit different. Obviously, you're going to be digging up a much larger area underneath the tree's canopy, but that's why we'd probably seek some advice on that. With regards to the drilling as well, any drilling areas that's near or in and around trees or the canopies, we would generally mobilise tracking boards and place those down on the ground, spreads the weight of the rig and protects those roots under the ground. So that's always something to think of. Moving on to the other question, how much space or how much access does the rig need? We'd say a minimum of 3 meters or 10 foot as a width is usually enough to get a drilling rig through and into a working area. We've just come off a job recently, actually. It was a 3.5 meter access down the side of a house. So you've got the building and the fence line. And we managed to get everything through onto the back garden to do all the drilling works and back out, not a problem at all. But again, what we'd always say, if you are worried about the access, we would be more than happy to visit any site free of charge to take a look at that and give you advice on whether a rig can or cannot get into your property.
I think that usually comes with the pre-site visit, doesn't it, to do a double check. So that's great. Thank you for that. I've also got Alistair asking, I have a gas-fired warm air heating system to Johnson and Starley. Would that be compatible with ground source heating? That might be one for Emma.
I'm going to throw that one over to Andrew or Lee.
Well, a warm air heating system will have presumably some sort of heat exchanger inside the unit. I noticed further down in the questions you've kind of measured the size of that, and it would really depend on what's feeding that warm air heat exchanger and whether a heat pump would be directly compatible with that as a heat exchanger. This is something we haven't done in the past. We have actually in the past removed warm air heating systems and put conventional radiator systems in instead. But it is, as Emma's explained, part of the process is working out whether you can get the heat into the building via either an existing or modified heat exchanger process, whether that's radiators, underfloor or anything else. So there's no quick, easy answer to that, really. I don't know whether Lee, do you want to add anything to that?
Again, it's just about heat exchanger really. Generally, a boiler system will be a high temperature system, so all the heat exchange equipment will be based around that. So again, it would be just having a look at that, and it probably would need upgrading and things like that really. So whether that's viable or it's just viable to install a new wet system, we just have to assess that really.
Okay, and we also have a question of what if the mains methane is replaced by hydrogen?
Emma?
Well, clearly they are exploring hydrogen. I'm not a hydrogen expert by any means. There is definitely going to be, probably an enormous sum of money spent on investigating whether hydrogen can replace natural gas. I don't think it's going to happen tomorrow. I think there's definitely from what I'm reading and what I'm seeing, there's a focus on that, firstly, in the industrial process, where they can have big gains over smaller infrastructure changes. The view that somebody's going to be down my street and upgrading my gas pipes to provide me with hydrogen is a long way off. I think it's going to spend a lot of money. I think, when you can do, what can I do? I can install a heat pump, or I can wait for the government to spend hundreds of billions of pounds looking at whether it's even feasible before we spend many hundreds of billions of pounds upgrading the gas network.
A lot of safety aspects involved there, aren't there, that need to be looked into?
I'm not qualified to comment, and
No.
I'm not going to sit here and dig out the hydrogen industry. I think there is definitely a view for industrial processes. I think the domestic case for hydrogen has, in my mind, yet to be proven, and in my mind, to prove the case is going to cost a phenomenal sum of money, whereas this is a proven technology. It absolutely can be installed. I mean, even if you read the recent Utility Energy Agency's report that says only 46% of homes in the UK can accommodate a heat pump. If you take that as the gospel, question mark, 46% of homes that tomorrow could be reducing carbon and really contributing to net zero whilst having low cost, low carbon heating system.
Yeah, I mean, I've got a ground source heat pump in my house. I'm not in my house at the moment, but I do have one. And we actually put some solar panels on the roof as well, for the hot water and things like that. So anyway, we've got some more questions here. Roughly how much do vertical boreholes cost, and what's the cost example include with the groundworks? So that's sort of a 2-in-1 really. So it's very difficult. I do know it's very difficult to sort of give you a rough cost of boreholes, but I'm going to throw that across to Jake and his team.
Yeah, so as you say, each property or each job will be totally different. You've got to take it on its own merits. But as an indicator, most of the works you can work them back to roughly around £5,000 to £7,000 per borehole, which includes for all of the external works that we do with the drilling, the grouting, the trenching works, but doesn't include for the internal works that the likes of IMS would undertake with installing the heat pump, etc.
You're likely to get something like 5 to 6 kilowatts from a hole, are you? Is that the kind of general ballpark figure that you'd suggest?
Yeah, I'd agree with that, yeah.
Okay, and Jake's asking as well, the 6 metre rule from the property, and also you would normally have the 6 metres between the boreholes as well. Is this to ensure the building structural integrity?
Effectively, it's a safety measure, yeah. There's no, so I'm told there's no specific rules. That doesn't mean that you can't drill the borehole closer to the property, but you should ensure that there's a minimum of 3 metres from any boundary with adjoining properties. So if they've got a ground source heat pump system on the opposite side as well, theirs will be a minimum of 3 metres from the boundary. So you've got a 6 metre gap between the two properties' borehole systems. So we generally try to keep that 6 meters away from the building. It gives you enough space for the rig and all the machinery and plant to get in as well without getting too close to the property. But yeah, there's no specific reason you can't go closer if you wanted to. It'd just be the risk if there ever was a problem that you might get some uplift close to the building's footprint.
Okay, thank you. I've got Ben asking, can you use an emergency heater as a backup for the winter?
But generally, the heat pumps will be sized for 100% of the heating and hot water requirement. So immersion heaters really are only required for what's called a Legionnaire cycle. So that's where it moves the hot water up to 60 degrees on a periodic interval. So we don't really need the immersion heaters, but we always include one for that facility, and also as a backup if there's any kind of problems with the heat pump system at any point.
Okay. Alice is talking about hydrogen again. I don't really think we've got much of an appetite for getting involved in that. If you don't mind, Anthony, perhaps you can take that offline with Emma if you wanted to later on.
By all means, yeah, I am, you know, without a doubt, still interested in the wider carbon conversation. I'd be happy to have the conversation.
Okay, and then we've got 2 RHI questions. At what stage does the installation have to be in March 2022 to be able to qualify? And will it still pay out for quarterly for 7 years? Now, I actually do receive RHI for my ground source, and I did it before the cap went on, so I'm quite happy. And I can assure you that the 7 years, every quarter, in it comes, the money comes straight in from the government into your bank account. So I believe that that will stay the same.
Absolutely, and my understanding is that your system will need to be in. It needs to be MCS, and you need to have an EPC, and your application will need to be lodged before the 31st of March 2022 in order to be on the scheme. In terms of a self-build or new build situation, what that would mean is that it needs to be in, and your property needs to be signed off the building regs in order to gain an EPC before the 31st of March. You have to have your application in. So it's not just about the heat pump being in a new build. You need an EPC, and in a new build situation, you're not going to get that until your building regs are signed off. In a renovation or retrofit situation, it needs to be in, it needs to be working, MCS commissioned, and an EPC generated, an application lodged. Once that application is lodged, assuming all is well and that you are accepted, absolutely, it's committed for 7 years. As Andrea says, the government just pays you every quarter. Thank you very much.
Yeah, it does, absolutely.
If I could just jump in there as well, Emma, on the back of that. People are worried about getting it in on time. Obviously, each drilling firm is going to be different depending on their commitments, but quite often, us, for example, we could mobilise to a site within sort of a 2-week lead time from taking an order. So the whole process can be done quite quick from start to finish if if people are looking to go ahead.
I will say on a heat pump installation basis, the sooner you get on somebody's books and in somebody's schedule, the better. Clearly, the impetus of heat pumps has created a bit of a frenzy. We are busy. We are taking. I've got jobs booked in my schedule until September. That's not to say that I don't have space. But it's filling up, and if you are looking for March, I would say get on board with an installer sooner rather than later.
I think that's absolutely
Don't
right.
leave it to the last minute.
Yeah, we're seeing that within the association as well, and within my own company, and I think a lot of us are seeing the same thing, that it's getting busy out there. So yeah,
absolutely, and the
expect us to come next week.
We don't know what the government's clearly considering something to replace Green Homes Grant RHI. They consulted on the Clean Heat Grant, which was a flat rate of £4,000. Clearly, it doesn't touch the sides in what you can currently get from the RHI. So really, funding's never been this good. If you're doing it, now is a really good time to get on board.
Absolutely. I have no more questions here, and we're coming up to the hour. So I would like to thank Emma, Jake, Andrew and Lee, and Stephen for working behind the scenes there for us. I think that's been really informative, and I'm sure that everybody that's been here listening will think the same. As I said at the beginning, live recording, and it will be on YouTube at some point, so you can go back and catch up, and Stephen will put the links on, and I'm sure Emma and Jake and the teams will be putting the links onto their websites too. If you do have any questions and you want to contact Emma or Jake, don't hesitate to do so. The number's there, and if you forget who we are, the Ground Source Heat Pump Association, look us up, and we'll point you in the direction of those involved today. So I'd just like to say thank you ever so much to everybody. Really good session, very informative, and thank you. Okay, good night.
That's all.
Thanks.
Thanks.